One. Yes, very good afternoon everyone. Welcome back to pantechelearning platform. I hope my voice is audible. Please let me know, my dear students, my dear participants. Is my voice is audible? This is R. Divyanjali from pantechelearning. Pantech is a place where a student can experience, innovate and implement different research and development works over this platform. And today's session is going to be conducted by RBVRR Women's College, Autonomous College. The Department of Computer Science is organizing a webinar on the occasion of National Technology Day 2022. That is on 11th May. So there is a small change in timings. At 3 o'clock in the afternoon we are conducting the session. And I would like to welcome all the participants, all the dignitaries to the event. Yeah, so we are going to discuss something about the application oriented session, right? The session is all about estimation of power consumption for household electrical appliances using machine learning. Generally, we can calculate the power consumption for overall household and for particular appliances also. So what is this machine learning and what we are going to do with this? Let us discuss now. Yeah, here comes the introduction. Nowadays there is an ever increasing migration of people to urban areas. Healthcare service is one of the most challenging aspects that is greatly affected by the vast influx of people in cities. Basically our problem statement is we are going to calculate the power consumption for overall household, okay? In existing model of system, there are number of works, techniques that have been present. For example, if you consider at right now, if you wanted to know what is the power consumption, how does we know generally? From the meter, a person will be coming, he will be calculating the power, electricity bill, he will be giving it, right? So that is one of the existing technique we can tell. In the proposed model of system, we are going to work with machine learning. What is this machine learning basically? Machine is learning something, right? The word itself is telling like a machine is going to learn something. How it is going to learn? For suppose if you consider a small kid, how does he learn? For suppose a kid of 1 year old, 1.5 year old, he'll get up, he'll walk, he'll fall down. Again he will get up, again he will walk, again he will fall down, right? There he is learning how to walk, how not to fall down. So he is learning from past experiences, right? In the same way, a machine also, for any problem statement in the universe you consider, It will consider it will collect the past recorded information. Using that data, it will first learn what that data actually consisting of. Then it will learn the data, then it will use that data for future predictions. Remember one thing, the main aim or the main goal of using this machine learning concept for any problem statement is just to predict the future. Why we have to predict the future? Here comes my question. My dear participants, this is not your regular classroom session, okay? You can even make the session so interactive by just answering me my queries in the comment section. Fine. And whatever the queries you are having, you can just ask me in the comment section. I will get back to each and every query by the end of the session. My dear students, here in the comment section, you people are keeping your name, your roll number, section, that and all you don't need to keep here in the comment section. We will share you the attendance link by the end of the session in the description box. There you can fill your details, then you will receive the attendance. Okay? I hope it is clear to all the students. Once again I am repeating, my dear students, my dear participants, you will receive the attendance link in the description box at the end of the session. So just wait and listen the session. Fine. So we are discussing something about machine learning. So why we have to do the future analysis, future predictions? We humans are very much excited to know what is the future. For any problem statement, for suppose you people are attending some exam and after the exam is finished, you are coming out of the examination hall. What is the first thought you will be getting? I think I may get pass marks, or I think I may get distinction, right? We are predicting something, we are estimating something, but we are humans. We cannot tell the correct estimation, right? But the machine can give me the proper accurate result. In this machine learning, we are going to work with algorithms where we apply different types of algorithms to my problem statement, to my input data. Then each algorithm, how much accurately it is able to predict, that is what we are going to find here. By that we can even compare the results by the end of the execution. Fine. Let us now move on to the next slide where we are going to discuss about the architecture. Generally in machine learning, before this architecture let me tell you, generally in machine learning we do have mainly three types of learning system. First one, supervised learning system, second one, unsupervised, and the third one is reinforcement. I repeat the statement, there are three types of learning system. First one, supervised, second one, unsupervised, third one, reinforcement. What is this supervised, unsupervised, reinforcement representing? Moving on to the first one, that is supervised learning. When a system is having some set of labeled data at the input, then we treat it as a supervised learning or a supervised approach. Here comes my question, what is this labeled data all about? For suppose I have all your college students details, something like name, college, branch, section, roll number, all the details I have, but I just wanted to access only the names of the student. Then I will give the column name as name of a student. Under that I can access all the names of a student. For suppose if I wanted to represent each and every student with their roll number, then I will give the column name as roll number. Under that I can access all the roll numbers of the students. Such type of attribute given data, column name given data, parameter name given data, condition name given data, that type of data is called labeled data. When a system is able to work with such type of labeled data, then we treat it as supervised learning. Moving on to the next approach, that is unsupervised. When a system is having some set of unlabeled data, mixed data, combined data, then we treat it as unsupervised approach. Moving on to the third approach, that is reinforcement approach. This is not needed for a project level. You can just remember like it is mainly used in game development purpose, and it is of two types: positive reinforcement and the negative reinforcement. Supervised and unsupervised is also of two types, like it can deal with two types of problem statements. Supervised deals with two types of problem statements. First one classification, second one regression. Classification type of problem statement deals with discrete values, whereas regression type of problem statement deals with continuous changing of values. That is what we are going to learn today. In the architecture, the first block you can see as data set, which is nothing but I am going to collect my input data. Okay, generally I will be collecting in the form of a data set, which is nothing but an Excel sheet data. Okay, after collecting my input data, I am going to give to a pre-processing stage where I am going to do filtration of my input by eliminating unwanted data, something like null values, white spaces, symbols. Such type of data will be eliminated, and we are going to do the filtration. After filtering the data, we are going to apply the algorithms to my input data by classifying the data into two categories: training and testing. How we are going to classify the data, that I will show you in the further session. Then each algorithm, how much accurately it is able to predict, that is what we can see here. Next is system requirements. We are going to have hardware and software requirements. Hardware of operating system Windows 7, 8, 10 of 32-bit and 64-bit, and RAM should be 4 GB. Coming to the software requirements, we are going to implement our project in Anaconda Navigator software, in Jupyter Notebook Editor window, in Python language. Fine. I will now show you how to install Anaconda Navigator software in your system. Go to Google Chrome and type Anaconda Navigator download for Windows. You can see here, this is the home page. Here you click on this download Anaconda. It will be downloaded in a file format. After downloading, double click on that file. A window will be appeared. Now just click on next, 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 and then click on finish. It will be installed in your system. Okay. Afterwards, go to start, all programs, and type Anaconda Navigator. Click on open. First it will open the command prompt. Then it will redirect us into the home page of Anaconda Navigator. Just wait, it is loading. This is the home page of Anaconda Navigator software. Among all the editor windows which you can see here, click on launch this Jupyter Notebook. Okay. Now go to start, all programs, and type Jupyter. Open it. It will first open the command prompt in this way, and it will redirect us into the home page of Jupyter Notebook editor window. Here you have to select the location first. Next you have to select the file. So click on your file name .ipynb. It will be opening your coding window in this format. So sorry for the interruption. I hope all the students are following. I hope everyone understanding the session. If you are having any query in the middle of the session, please let me know that in the comment section. So here you can see this is the Jupyter Notebook editor window coding file. A rectangle box you can see, right? This is called as a cell. Whatever the data you are writing within the cell, it has to be saved with save and checkpoint. And if you wanted to add more number of cells, click on the plus symbol. If you wanted to delete information, click on the cell outside so that the cell is selected. Then click on the scissors. It will be deleted. And copy paste in the same format. Then we can even run the code in two ways. One is click on the cell and click on run symbol one after the other line, and the other one is click on shift plus enter on your keyboard. Fine. Now I am going to explain you the code each instruction by instruction. Just listen, my dear participants, it is very easy to understand. Okay, fine. First, import system. Okay, next, this is a module used for accessing of input data from the system. Okay, next, NumPy. So you already know we are going to work with Python, right? Why Python? Is because Python is a basic beginner language. Even with the basic beginner of 0% knowledge also can start working on this language, and within no time a person can develop different applications using this Python language. It's like an English language, very easy to understand, user-friendly language, which is having more number of features, making it so special. Okay, fine. Import NumPy as NP variable. NumPy is a library file which is basically used for accessing of numerical values and for numerical calculation purpose, and it is represented with NP variable. We can give any variable representation over here. By default I have mentioned something like NP. Next, pandas. Pandas is a library file which is basically used for accessing of input data from my input file, and it is represented with PD variable. Next, matplot library.pyplot module as PLT variable. Matplot library is used to visualize the data in graph. From this matplot library I am using pyplot module as PLT variable. Next, Seaborn library file. Seaborn library file is basically used for customization purpose, something like color indication, graph, size, length, like that, and it is represented with SNS variable. Now, from sklearn. Sklearn is a library file which is used for accessing of machine learning modules or machine learning algorithms. So from this sklearn I am using model selection technique. From that I am importing a module called train test split module. Why we are using this, I'll explain you further coding. Okay, fine. Let us move on to the next instruction. From sklearn.preprocessing technique I have imported min-max scaler. This module is used to normalize my data. Okay, next, from sklearn I have imported metrics module. Metrics is a module which is used for mathematical calculation purpose. Fine. Let us move on to the next cell. This is my input file which is in text format. Okay, that file of data I am separating the whole file with separating with semicolon. Wherever I find this semicolon, it should enter into the next column of data. Okay, next, parse dates. I am giving the date and time information, memory data and non-null values to be replaced with question mark. Okay, fine. And the whole input data I am reading into the program with the help of pandas library file, and I am storing in a very small variable called df. Now for this df I have applied header function which will give me the first 5 rows of data with all the columns. So my input attributes conditions consist of global active power, global reactive power, voltage, global intensity, submetering 1, submetering 2 and submetering 3. Okay, this is all my past data. Okay, next for this DF I have applied D types. It means data types. So which type of data type it is consisting of, that attribute, particular attribute is consisting of. All are floating point only. Okay, next comes dot shape function, which will describe me total number of rows and columns present in my input data. Next, columns. Columns function describes what are all the columns that are present in my input data. Now, first I am giving something like dropping list all, right? This is a variable where I have given something like empty data. Now, for j variable within the range 0, 7, my whole columns are, how many are there? 0, 1, 2, 3, 4, 5, 6. 6 columns are there. In order to access all the 6 columns, I have to give the range from 0 to 7. Okay. From first range till n minus 1 range, it will access all the columns information. Okay. If not, I location, wherever we do not find any null values, that data it will consider and it will be adding to the list of data. That list of data you can see here. All the columns data I have been accessed. Now for j variable within the range 0, 7 and the location is being mentioned here, the mean values to be calculated. Next I have applied isNull.sum function, which will give me whether there are any null values present. If present, how many null values are present for each and every column, every attribute. That is what it is going to give me here. Fine. Now I am going to divide my data where all the columns except submetering 3, all the columns to be stored in X. Only submetering 3 column I am storing in Y variable. Now if I execute this X, I am going to get all my data except submetering 3 column. Okay. Next line. Yeah. From sklearn.model selection technique, I have imported train test split module, which is basically used for splitting of data into training and testing category. Why we have to divide the data? Here comes my question. Can anyone answer it? My dear students, can anyone answer it? Why we have to divide the data? Why we have to divide the data? Just guess it. Why? Because for suppose if I give some input data and ask the system to give certain predictions, future predictions, the system don't know anything. It is just like a doll, a toy. Okay, so it don't know anything. First it has to learn something, right? That's why we are dividing our data into training and testing category. That's why we are using this train test split module. How I am going to split the data, I will show you now. I hope everyone can see the screen, right? For suppose this is my Excel sheet data, which is consisting of some number of rows and columns. This is all of my past recorded data, right? So I will have my input as well as output also for my past data. Input is represented with X, output is represented with Y. So this is my whole data. I have to divide my whole data in certain ratio like 6:4, 7:3, 8:2, 9:1. In this ratio, I have to divide my data into training and testing category. Why only in this ratio? Because as per the rule, more amount of data should be given for training purpose, less amount of data should be given for testing purpose. Fine. Now I'll consider any ratio we can consider. I'll consider here as 8:2 ratio. It means 80% data has to be divided. This 80% data is called training data. This 20% data is called testing data. Now this block of data becomes X-train data. It becomes Y-train data. It becomes X-test data. It becomes Y-test data. X-train, Y-train data is used to train the model, train the algorithm, to make the algorithm understand what my input data consisting of. Whereas X-test is our estimation that system may give this much amount of prediction. That is what our estimation. Whereas Y-test is the actual prediction that system is going to give me at the output. Fine, this is how we are going to split the data into training and testing category. So I am applying this module to X and Y variables. Test size I have mentioned 0.2, it means 20% data. Remaining 80% data I have to give it for training purpose. Random states 42. We can give any number of random states. It might be 0, 50, 100, 101, any number of random states we can consider. In this format, I am dividing my data into X-train, X-test, Y-train, Y-test. Now, from sklearn.linear model selection, I am importing the algorithm called linear regression. Okay. So, linear regression comes under the regression technique of supervised learning, where it is going to plot my data in a linear line. When X value increases, Y value also increases. For suppose, this is linear plotting, right? If this X value increases, Y value also increases. So now you see, from sklearn.metrics I have imported R2 score because I wanted to calculate my output in terms of regression score, right? So R2 score I have imported. Now taking the algorithm into a small variable. Next I am fitting the training data to this variable. Next Y prediction to be calculated with the help of X-test data. Now it will print this Y prediction, where I am going to calculate the score with the help of Y-test and Y prediction values. Next it will print that score with the help of Y-test and Y prediction values. Let us see what is the output. First I will get the output in terms of array of elements. But I just wanted to get the output in terms of score, right? That's why that score is given here. 0.47. It represents 47% accurately. Linear regression algorithm is able to predict my data. Fine. From sklearn.ensembling technique, I have imported random forest regression algorithm. This algorithm basically used for multiple conditions. For suppose, I'll show you now. It is basically used for multiple conditions, okay? So I'll take three conditions like A greater than B, A equal to B, A less than B. For each condition I will have two probability, that is whether the given condition is yes or no, yes or no, yes or no. Okay. So based on yes or no condition only my output should be determined. But here, as I have different conditions based on majority voted output. For suppose, two outputs are representing yes condition, one output representing no. So based on majority voted output only, the actual output will be determined. That is about random forest algorithm. Now I am taking the algorithm into a variable. Next I am fitting the training data to this variable. Next prediction to be calculated with the help of X-test data. Next score to be calculated with the help of Y-test and Y prediction values, which will be printed now. You can see here R2 score value 0.70. It means 70% accurately random forest algorithm is able to predict my data. Next I am going to compare the results. Okay, which algorithm gave me the best possibility result actually? Which algorithm gave me the best possibility result? Random forest algorithm, right? So that I have to plot the data in graph. Import matplot library.pyplot module as plt variable. Objects taken as name of the algorithm. Y position taken as length of the objects. Performance taken as the how much accurately it got the output. Going to plot my data in bar chart, that is next x label, y label, title is assigned. When I plot the data, you can see here, yeah, this is what your output is. Okay, we are just comparing the results. By comparison, we can tell like random forest algorithm is giving me the best possibility result as compared to linear regression. Okay, how to execute the code? Just click on the cell, click on run symbol one after the other line. So this is how we can execute the code. Do you have any doubts regarding the project or the application we have discussed? First of all, did you understand the session? My dear students, my dear participants, please let me know if you are having any queries. We are discussing machine learning, right? What is this machine learning? Where it has come from? You might have heard about AI, right? Artificial intelligence technology. What this technology basically representing? So something like inserting our human brain intelligence into a very small computer so that the computer will have the ability or capability to work same like our human brain. It's not an easy task to be done in 1 day or 1 hour or 1 week or 1 year also. That's why number of research development works are going on under this technology. Under this research and development works only, we got certain domains like machine learning, deep learning, data science, all these domains, NLP, all these domains came into existence. Understood? Now you might be knowing why we are using machine learning. Machine learning is used for future predictions. Okay. Whereas deep learning, we also get the accurate results in deep learning, whereas in machine learning we work with algorithms. In deep learning we work with neural networks where we can create a network and store our data so securely, then find the predictions. NLP is like an application of ML, where in machine learning we generally take the input in the form of a data set. That is nothing but an Excel sheet data. Whereas in NLP we consider the input in the form of sentence or something like paragraph information as my input data. Okay, I hope everyone understood the session. Do you have any doubts regarding the application? Any doubts regarding my session? Please let me know. I am waiting for your queries, my dear students. Any queries? I hope there are no doubts, no queries. You are waiting for attendance link. You will get the attendance link by the end of the session, don't worry. And any more doubts yet to be clarified, please let me know. I hope everyone enjoyed the session, right? No queries? That's good to hear. Fine. So before winding up the session, I'll give you one small tip. Whatever the domain or whatever the technology you are interested to work, you can just focus and take the basic steps. Learn the basics. If you can learn the basics, you can build in the same domain, same technology to build up your career in the best out of the best. I hope everyone will utilize your career job opportunities, and all the very best, my dear participants. Have a very nice time. Now I am winding up the session. Before winding up, I would like to thank the college management with all the participants for attending the session and making my session so interactive. And also, last but not least, if you like the session, please do like, comment, share and subscribe to pantechelearning platform. Thank you all. Have a very nice time. Thank you all.